Okay, this is our angles of triangles 5-1 worksheet, and we have a triangle sum theorem which tells us that the sum of the angles inside of a triangle, like a plus b plus c, is equal to 180 degrees. And I kind of set up a little proof over on the side, setting up a parallel line, which is the red dashed line. By alternate interior angles, we can jump that measure of angle 3 up to the top, and then we can do the same thing with angle 1 using alternate interior angles on the other side. So we can see that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. So this is like a pretty easy little proof proving that the sum of the angles in a triangle are 180 degrees. So let's look down at this diagram, example 1, where we have to find the measure of these angles. Usually we try to start with vertical angles and with linear pairs, but in looking at this diagram, I can see that triangle LKM, it's pretty easy to figure out what angle 2 is, since they all have to add up to 180 degrees. So when I combine like terms and set it up, I have that 128 plus measure of angle 2 is equal to 180, which leaves measure of angle 2 equal to 52 degrees. Now I still don't have enough to do the top triangle, but if I look at L, I can see that angle 1 plus 57 are a linear pair, which means that they add up to 180 degrees. So if I take 57 away from both sides, I end up with 123 degrees for angle L, for the other angle at L. Now with the top triangle, we have 123 plus 28, and that with angle 3 has to add up to 180 degrees, and 123 and 28 is 151. So if I subtract from both sides, we get the measure of angle 3 is equal to 29 degrees. Okay, let's move on down. We have some new vocabulary talking about interior angles. If we look at the triangle, the shaded area, angle 1 plus angle 2 plus angle 3 are interior angles. And I just drew an exterior angle, and we'll call it angle 4. So one at each vertex. If you extend the baseline down sort of like a pinwheel, you can also find exterior angles. Now our exterior angle theorem tells us that the exterior angle is equal to the sum of the two remote interior angles. For this example, angle 4 would be equal to the sum of 1 and 2. So let's look at some of these remote interior angles. Angle 2 is an adjacent interior angle. Angle 1 and 3 would be remote interior angles to angle 4. What the hell? So by the exterior angle theorem, measure of angle 4 plus the measure of angle 3 is equal to 180. And we also can say that measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals 180. Or really with that first one, measure of angle 4 plus measure of angle 3 equals 180 because that's a linear pair. But we can set 180 equal to 180 and substitute both of those in. And then if we take measure of angle 3 away from both sides, we're left with measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 2. So in that proof up on the right, it's a pretty simple algebraic proof showing that the exterior angle is equal to the sum of the two remote interior angles. So let's move on down. So let's look at the diagram of this house. Now if I look at the pattern here, we see that it's really an exterior angle pattern. The angle DAB is the exterior angle, and the angle at B and the angle at C are the remote interior angles. So we can see that we can set 12x plus 7 equal to 6x minus 4 plus 65. And then we're going to solve for x and then plug in and find the measure of DAB. So x plus 7 which is DAB, is equal to 6x minus 4 plus 65. 6x minus 4 plus 65, so when we simplify we get 6x plus 61, and ultimately we find that x is equal to 9, so the measure of DAB is going to be 12 times 9 plus 7, which is 115. Okay, last diagram on these pages. Find the measure of JLM. Again, we have an exterior angle. 9x plus 10 is going to be equal to the sum of the two remote interior angles, 7x minus 5 plus 35. So we do the algebra that goes with that. Then we're going to combine like terms. Minus 5 plus 35 gives 30. So 9x plus 10 is equal to 7x plus 30. Take away 10 from both sides, take away 7x from both sides, we get 2x is equal to 20, which leaves x equal to 10. So we plug that in. 9 times 10 plus 10 gives us that the measure of JLM is equal to 100.